think we should be good. Perfect. All right, so again, I do want this to be interactive. I've got about 20, 25 minutes of slides, and the remainder we can ask questions. I'm hoping that I at least trigger some questions in your mind. But with that being said, I do have a QR code. I said that earlier. If you scan it, you can interact with me with the slides. Right off the bat, I've got a question for you. And that would be, as this loads, oh no. I did check this first already, so we should be good. Should be. Oh, come on. Don't do this to me. Maybe I don't have a QR code for you. If I don't, then we'll just proceed. Well, basically, my question is, and you guys can just throw answers out there, what are the most annoying buzzwords that you guys have in IT? I mean, there are a lot of buzzwords out there. What are the most annoying ones?
Not available until quarter 4, 2023.
That is true. But one of the ones that I've heard a lot of is zero trust. Everything is about zero trust. And yes, you are here for zero trust, so I'm going to try not to bore you to death with zero trust. But it is a necessary evil, if you will. And as we, I'll just move on. There is an official zero trust definition, and I'm not going to read it to you because it is a buzzword. It's long, it's annoying, and I really want to just give you my take on what zero trust is. And zero trust is, and I'll read this one to you. Zero trust is the understanding, or the understood inability to trust anyone or anything under any circumstance with access to your data or systems. It includes the ability to monitor and revoke access if suspicious or unwanted activity is identified. All of this while maintaining minimal impact to users or operations. That minimal impact to users or operations, I think, is really key here because historically, zero trust has been pretty user impactful. As we add application whitelisting and things of that nature, we end up impacting our users. So let's define what it's been. Historically, zero trust has been location-based, LAN versus WAN. Where are you accessing the data from? Where are you coming from? It's stopped, stuff is stopped at the perimeter with a next-gen firewall using IPS, IDS, or other security services. And then we have micro-segmentation of services, devices, or types to control access to specific types of data or specific services or applications. What do I think it's going to become? Well, where I think we're going is with next-gen zero trust, or what I believe the next generation of zero trust adds application whitelisting, the inter-application zero trust or ring fencing, which I'll get into a little bit more here in a bit, privileged access management, elevation control, micro-segmentation by group or user instead of the IP service, which we've been using historically in zero trust access, or excuse me, zero trust environments. And as we, I won't talk about this one too much, but ZTNA I think is going to be a critical element going forward with zero trust in how we access our data and our services. HighPoint has well, I'll back up a little bit, sorry. There's a lot of tools out there today that do some or multiple of these items that I kind of touched on. We've got, I probably shouldn't name any vendors. We've got a lot of vendors here. But HighPoint really has centered on ThreatLocker as our key zero trust, or endpoint zero trust vendor. And the reason that we've done that is because of how many of those boxes that they check. ThreatLocker does add that application whitelisting, the inter-application zero trust, that ring fencing, privileged access management, elevation control, audit logging, storage control, network access control, etc. I didn't expect this many of you guys. I apologize. Really, the reason that we've centered on ThreatLocker really is because application whitelisting has been a problematic element for a lot of environments for a long time. We've got a pretty heavy lift when it comes to implementation, a pretty heavy lift when it comes to controlling and locking down. We've had, I've been on several calls where customers have had pretty heavy user impact, which doesn't go well when you're trying to run a productive business. And so really the way that that ThreatLocker does application whitelisting and that ring fencing is very unique in that the deployment method allows us to deploy without impacting users and monitor that situation, monitor what's going on in the environment without having to impact those users. We're able to do what's called simulated denies and look at what would be, if we were to lock down today, what would happen in the environment? How would our users be impacted before we actually do that? And then we can actually start to lock down those users and those endpoints by group, by machine, without actually completely stopping work for the entire organization. When we get into that inter-application zero trust or ring fencing, that allows us to control the application's communications with other applications. As an illustration, your Chrome browser has access to basically anything on your computer. If your browser was to be hijacked, there's nothing that it doesn't have access to. What ring fencing would provide is the ability to control how that data is accessed, what it can access. Basically saying, Chrome, you can't access my whatever you name it, your ERP, your QuickBooks, whatever it is. You can actually lock that down and only allow Chrome to access the files and the things that are necessary for Chrome to operate. Let's just use that as just a single illustration. But moving into other things, we've got privileged access management. So privileged access management allows us to I'm going to combine these two, that elevation control and privileged access management. But we've now defined what Chrome can and can't do. What happens when your users get into a situation where they need to do something that might be outside of the bounds that we've set for that application? That's where we get into this elevation control and privileged access management. If we run into a situation where your users need to access something that isn't currently available to them by policy, they have the ability to request access to that. We can then provide that, and this is where we get into that elevation control. How many times have you had to go to your user's workstation and put in your credentials? Or, God forbid, you said, I'm sick of entering my credentials, I'm sick of going to this user. We'll make them a local admin or a power user, or whatever the case might be. You've now added a pretty major security hole in your environment when you've allowed them to be local administrators. So what I would propose is that if we were to add some elevation control to that request for that application, so I'm kind of going through this illustration, but basically the user asked for something that they don't currently have access to. We have a request. We can control whether or not that specific application, not the user, would be able to be elevated or accessed by the user. We can write that as policy. We can write that as a one-time thing. We can give them time-based access just to that application, or we can make it a permanent policy. So I feel like I'm doing a poor job explaining how that can reduce your overhead as IT staff. But basically, you've now been able to define what applications your users can actually interact with, and if that needs to be elevated or not. And again, I don't have the illustration here today, but basically that elevation process will happen only to that application. It isn't a user-based elevation, so it's not like that user has access to everything, which is pretty cool. A key component to all of this is knowing what is happening in your environment, being able to audit what's happening. What applications are accessing my data? What applications are accessing other applications' data? So being able to actually filter that audit log, being able to see what is happening in your environment is also a key element. Because to be honest, just having tools in place doesn't help you. You need to be able to track what's happening, be able to define what's happening, be able to see what users are requesting. And a key component to this is simplifying your users' access to their data, to their applications, because if we can identify what they're accessing, we can predetermine policy. We can write policy before it becomes a problem for them. So really at the end of the day, what we're doing is simplifying access to data and applications for your users. Another benefit here, similar to this application control, we have storage control, being able to define, again, what applications can access not only other applications and that data, but basically how they can access storage areas. That would be local disk, that would be shares, that would be any sort of network resources. And then a new component that we're still working through, and maybe Colin can give us some insight into network access control here in a minute, but it's a pretty new feature for ThreatLocker. We're still wrapping our heads around it, but adding that network access control is pretty important as well. All right, so I have a funny illustration. You guys all say, well, I have endpoint protection. Why do I need this? Well, the reason I think you need this is I'll use a bouncer approach. I'll use a kind of a bouncer illustration. But basically, antivirus is the bouncer. It's an ID checker, metal detector. It tries to identify any malicious tools, any malicious weapons, if you will, at the gateway of the network, at the start of the communication. It tries to identify those fake IDs. Where endpoint zero trust comes in is you're not only checking the ID to make sure that you've got the right people, that your party, if you will, but you're also locking the doors that they cannot go to. If there's a specific area, just say of your house, I was thinking of kind of the TSA, how they kind of funnel you through their metal detectors, etc. But we're defining what doors they can open. They might be able to go to the bathroom. They might be able to go to common areas, but they can't go to your den. They can't go to your bedroom, etc. So that's where endpoint zero trust comes in. We can lock those doors so they have access to what they need to have access to, but don't have access to what you don't want them to. I like how ThreatLocker actually, I believe it's allow what you want, block everything else. Is that correct? And that's the way you want to think about this with how endpoint zero trust would help secure your environment. I think of like Log4Shell. I think of like the Exchange vulnerability of last year. Those are actually good applications. They are known good applications. They passed the bouncer. However, they started doing things that we didn't want them to do. And if we'd been able to ring fence those, if we'd been able to say, well, you can do this, but you can't exfiltrate data. You can't steal my hashes out of Active Directory. You can't do nefarious activities because we've already defined what we know you're supposed to be able to do. You can't do this stuff. So using that endpoint zero trust model, that endpoint zero trust logic, it doesn't matter if you have a 0-day. We're going to try to avoid those. We're going to patch them as soon as we can. But think of Log4Shell. How many of you were affected by Log4Shell? How many of you don't know you were affected by Log4Shell? Log4Shell was in everything. Log4j was in everything. So I'm sure that most of you probably have some application that was affected by it, whether you know it or not. But in that situation, with those applications being ring-fenced and being able to be controlled as far as to what they're supposed to be doing versus what they shouldn't be doing, 0 days really they're not a thing of the past, but they're not at the forefront of our minds. They're not as scary, if you will. They're definitely a critical vulnerability that needs to be patched. But in the case of Log4Shell, I still don't think some applications have been patched. I can think of 1 or 2 that I've seen even recently that are still not yet patched. And unfortunately, that's just because of the vendor. I know that the actual application, the actual executables were patched, but if your vendor hasn't implemented those, then your application still isn't patched. And you can't just, as far as I've seen, you can't just rip and replace those. You probably end up breaking your application. So what I wanted to do, and actually I kind of wanted to bring Colin up here because this is one of ThreatLocker's actual graphics. But there are 3 elements to controlling and securing your environment. There's the detection side, which would be that EDR, AV, your anti-phishing, etc. Then you've got your elevation control. You've got your actual controls of the environment, which is that endpoint zero trust stuff that we've been talking about. And then below at the bottom, we've got your security awareness training, which would be, as John was discussing, your human element, making sure that your users are aware of what risks are out there. But yeah, I'll hand this over to you for a second. So this is Colin Ellis. He is our ThreatLocker sales engineer, and it's been a lot of fun working with him. So if you want to run over that a little bit.
Perfect. A pleasure to meet everyone. I'm a senior solutions engineer at the ThreatLocker side of the house, and I work directly with Caleb and the rest of the team as far as implementation, onboarding, and really making things make sense. So you'll notice as he stepped through the slide deck, one concept that is always going to be present is this idea of control. Every technician, every engineer in this room, in order to make something like zero trust make sense, like he mentioned, having visibility into what's there is great, but now the controls to actually answer the how is where we end up making the difference. So going back to the visibility concept, I won't get too technical here, but want to preface this for you guys. So whenever the agent is installed, it's a service and a driver, and they live at the kernel. So we can break down the architecture, but just know the kernel, the OS. So if you put a policy in place that says your highest privileged admin, your domain administrator, the person in the company with the keys to the kingdom, you get to say, despite how you're privileged, you can never exfiltrate data. You might have access to your RMM. You might have access to something like PowerShell. But from top down, the company understands exactly how those things should be used. So that's all we allow. So the concept behind zero trust, like you mentioned, it's a huge buzzword. Not just today, but for the past 2 years, it's been mentioned to you guys over and over again. But it always comes back to having explicit visibility and then the actual ability to say, I can control what's going on. So typically when I do my product demonstrations, my reviews, I have a knack of picking on vendors. Some of those vendors might be here, so I might not pick on them too much. But the idea is very simple. If we know you're leveraging a backup tool, does it make any sense to you at all that something like Exchange, that something like Office can touch your backups? It doesn't. And when you guys are building out your policies, especially with GPO, you build those policies with those things in mind. But the biggest issue here is that we're only controlling users. What happens when Exchange is compromised? I'll give you this breakdown. That compromise was so bad, I have a 17-year-old little brother. He is really good with Postman, so he could authenticate as the system on that compromised Exchange server. So the biggest issue now is not the fact that it's a 0 day, but how long did that patch take to come out? So now you're dealing with that delta in time. How quickly can you remediate? Well, it's like Caleb mentioned, we're not looking to say, well, we're not worried about 0 days, but if we know from the very beginning that Exchange shouldn't touch our backups, there's less to worry about. The only tool that has that capability at the user level, at the system level, is your backup. So the goal of this zero trust conversation is not to make things more complex, it's the complete opposite. We know what good looks like, and that's all we define, that's all we allow. So allow listing is not something new. It's been around, it's been that standard, but like he mentioned, I feel the ThreatLocker team makes this palatable because the biggest issue with whitelisting is change. The moment Windows updates rolls around, Patch Tuesday, if any of you have implemented a whitelisting tool before, you know Windows updates break everything. So instead of your team managing 80,000 files, we just do it for you. So we offload that burden as far as keeping the identity portion of the conversation succinct. And that's the goal. If we can make sure you know your RMM tool is legitimate, the updates they're pushing out is legitimate, that eliminates the burden. But in all honesty, what makes us a differentiator in the security conversation now is the ring fencing control, like he mentioned. It doesn't matter what the app is. If the app has the same level of access you do, if it's compromised, that's all it takes. Think about your clients currently. Think about, I like to pick on the financial members of the team. I am not a fan of CPAs because they make my life a little bit miserable. So financial members of staff, I pick on them quite a bit. The tools they use, QuickBooks, no matter what it is, it typically requires them to be privileged. So as an exercise, whenever you guys get back, look at any financial member of your staff and ask them to open up Chrome, like he mentioned. If they can open Chrome, file open, Control O, and touch a share, touch a backup, that's the easiest way for data to be exfiltrated. So conditional access, all these buzzwords that you hear day in, day out, the question is always very simple. How do you implement that? And that's where we come into the picture. So instead of you and the team kind of racking your heads to piece these things together, they're templated for you. Ring fencing is a threat locker best practice, and you get them from day one. And I think your favorite policy is going to be the one we give you on something like PowerShell. Outside of those financial users, how do you stop your technicians, the people with the tools, from misusing them? We just wrapped up that presentation, and his business partner is the biggest hole in that whole equation, the members of the actual team. So that's what we're looking to do. If we can show you everything that's taking place, it makes it really easy for you to build those policies and make them effective. And that's really the goal. So the last layer now, this network access control. So keep in mind, we're endpoint based. What this allows us to do is we give you firewall control over everything. So we're not saying get rid of your perimeter at all. We're looking to reinforce that. Think about the gaps your firewall right now opens up. You can determine what goes inbound, outbound, but east and west traffic. If you have two machines right next to each other, what can your firewall really do about RDPing from one of your endpoints to another server on your network? So that's where we get to say segmentation doesn't have to be a job. It doesn't have to be a pain point. You don't have to put copious amount of hours into something like that. If you want to tether a connection between two devices right next to each other, it's one policy. You just deny it all. So the goal of Zero Trust and the way we're looking to bring it to market is to make it as simple as possible, and it becomes easier if you can see everything. And that's going to be what we reinforce day in and day out. So NAC, latest addition to what we provide, and you get to build on that. What about those clients, those machines that don't have a network in general, just work groups? That's where you get that consistent policy control. And the goal is to make sure that the endpoint itself is what you have control of. Yeah?
Cool. I think that's really all the content that I had, but I really wanted to open it up to you guys for questions for both Colin and myself, from either technical questions or procedural questions or anything like that. Is there anything that jumped out to you guys? See if my QR code works this time. Looks like a no. Yeah, and I did make sure. I checked it earlier, so I don't know what happened. Oh well.
You had that acronym ZTNA.
Yeah.
Previously,
Zero Trust Network Access. So that would be being the ability to control client access to, or workstation or PC or user access to your network based on a set of criteria. Is it up to date? Does it have current antivirus? Does it have my company policies in place? Is it on the domain, etc.? So being able to define that. It's basically, I would say, it's really building on like an SSL VPN connection, but being able to define what the criteria is for that endpoint to be able to connect to the environment.
certain applications like this, do they work with like a trust broker product to promote those policies and that ZTNA capability? Would, is there a difference between the endpoint piece for zero trust versus, using a different type of broker to enforce?
So, to my knowledge, ThreatLocker doesn't include ZTNA. I have that. That was really more just the future of zero trust, if you would, is including ZTNA, moving from that SSL VPN location-based access to conditional access. So ThreatLocker doesn't necessarily include that. That would be something that.
Yeah,
Okay.
regards to the combination of the two.
Okay.
Utilizing, again, certain technology pieces to be able to create that, I guess, different cultural capability, and working with specific applications and getting those out. So it's just, how do you see them working together to create that universal capability, in the sense that specific applications to going into now removing your firewalls and VPNs and pieces like that, just going to a different, like I said, a broker
Okay.
piece.
So correct me if I'm wrong, but the broker piece in this conversation you're mentioning might just be the identity aspect of the user itself. Is that what you're kind of
It
getting
could
at?
be. Yeah, so like, again, then it goes into a little bit about, who you are, the policies you have in place, and then
Oh,
the other.
the people in the back want to hear you. Sorry. No pressure.
No worries. I just I have my own understanding of this architecture or this ideology, and I was just wondering if I was on the right page, or if how your application would work with the continuation of building out your infrastructure for zero trust. Because I mean, it's a portion of what it is. It's not the whole solution. So I was just.
Are you asking would Endpoint Zero Trust or Threat Locker be able to work over a Zero Trust network access connection? Am I understanding you? So
To a
does that
point.
extend?
Yes.
Yes.
Working in conjunction with those other layers.
Right.
So definitely.
Yeah, it does.
To build on that, I'll give you a few examples here. So starting with the identity piece, I'm going to pick on Okta here. So if you're a fan of Okta, I'm also a fan. But the reality of where things like single sign-on and that type of identity access management comes back, if you don't mind, feel free to head back to the triangle. And this is where I love to dive in on this conversation. So the detection side, not really a part of this specific thing, but we're going to head more over to the controls. So you'll see dual factor, MFA, the identity layer there. So we're going to work in conjunction with all of that. What we're saying is the endpoint itself is what you have total control over. Because we sit at the kernel on those machines, we can break down any AD group ties. We can build policies around your OUs and how you've configured that currently. And if you're layering in an identity management tool on top of that, it's the same thing. The user still lives on the machine, and we bridge that gap. So if you're looking to say, just using QuickBooks as an example, QuickBooks can be available for everyone in the organization if you see fit. Or if there's one financial member of the team on top of your MFA, the identity portion that confirms who this user is, now this user can have access to QuickBooks on any device inside of the network or on just one endpoint. So the scaling allows us to target just about anything you see fit. It's not a silver bullet, because if we were to say Threat Locker solves for everything, we're just covering the endpoint. You still have that network layer outside of the physical network itself that we don't play at currently. So it has to be able to scale and work in conjunction with everything else from that zero trust mentality. But what I'd like to say here is that the biggest difference in our approach to zero trust, again, is going to come back to the endpoint. From the presentation that we saw today, humans are a big portion of this equation. But when the human error pops up, and it always will, whether that's members of your team, members of your clients, the staff, whoever it may be, we know this portion of the triangle will fail. It's a given. So when this element fails, when the identity fails, when the detection fails, what's left? We still have control of the machines. So I'll be giving you guys a quick intro today, I believe around 11, but the example is actually going to pick on Microsoft. Like I mentioned, I pick on vendors quite a bit. So the Microsoft example is tied to Felina. So everyone in here, I know for a fact you've gone through your security awareness training. I saw your hands raised earlier. So that security awareness training says we want people to become a human firewall. But what if you never have the opportunity? Felina was such a nasty vulnerability. The user just had to open the document. That's all it took. So whenever the human element fails, that's not a failure. They can still go through and be that firewall, but it's already on the machine. And that's what we're looking to give you control of. We know Bob in accounting knows diddly squat about PowerShell. So why does a document being opened execute code? So those are the things that we get to draw a firm line in the sand and make a big difference with if we are controlling the entirety of the endpoint itself. So hopefully that answered your question, but at the end of the day, it's made to scale. Because we're on the endpoint, everything else is just another layer. Far away. Okay. So ring fencing, this is it. It's total control. And because we run from the kernel, you think about some attacks that are fileless. File-based attacks, well, we kill that automatically. That's where whitelisting comes into the picture. Ransomware, malware, it is software written in a few different languages, but if that software is approved, it can never run. So ring fencing gives us this ability to say, even if you have a trusted vendor, we can pick on Exchange, we can pick on Kaseya VSA, any tool, it doesn't matter. Anything on your whitelist is a ticking time bomb. And it comes back to this human element here. You can do quite a bit for your team, for your clients in controlling what they're doing, but your vendors, you have no control over their secure development. You have no control over Microsoft. If that was the case, Patch Tuesday wouldn't be a thing. But because Patch Tuesday exists, you know every vendor goes through that, even us. So the idea here is to say, if that human element fails at any point in time, we know this tool, whether it's Exchange, whether it's the RMM, it has a few things it should be capable of doing, and that's what we outline. So file-less malware now, that's the thing that makes the big difference. If you can compromise a server without running software on it, you're in hot water. So what we get to say now is that it doesn't matter who's logged in on the system. It doesn't matter how a process is permissioned. The moment it steps outside of its lane, it's denied. So I'll pick on the pipeline. It's something I love to talk about because that MFA layer just wasn't there. What happens when identity is just gone? Well, you can look at anyone on your team and say, invoke a web request on PowerShell. Right now, if you can pick up your computers, have PowerShell speak to Google. You can exfiltrate data that way. You can be encrypted. So what ring fencing is saying very plainly, we already understand how everything in our network should behave, and that's all we allow. That is it. So log4, he was mentioning that a lot of you guys might not know you were being targeted, and it's because of the type of vulnerability. Log4 isn't looking to run malicious code. It's looking to talk to PowerShell and command prompt directly without you knowing. If you think back to, it's really similar to Eternal Blue in the way you can exploit those out-of-date machines in that way. You're not running software. You're not running new software. You're just using what's there. And that's what ring fencing hones in on. We know exactly how the system should behave, so now you get to outline that. And the biggest difference is going to be your tech team versus your customers. The way your tech team uses PowerShell makes a lot of sense. Your customers having PowerShell talk to the internet for any reason whatsoever, it's bound to lead to something malicious. And that's the goal. So you guys know better than I do. Windows was never made to be a secure platform. Mr. Bill Gates basically said, what is the easiest way we can get this done? And that's how PowerShell was created, just to simplify it. So if you have this tool that no matter what firewall, no matter what layers you put in place, PowerShell can still talk to any server on the internet. Doesn't matter what you put in front of it. When you guys leave this room, pop open your computers and just invoke a web request to anything, and you'll see it pull down that information. And that's the issue. You already have PowerShell running, so these tools on the left side, not that they aren't fulfilling their right, but they've already done their job. They know PowerShell is legitimate. so they allow it to run. PowerShell talking to a server isn't inherently malicious, and these attackers, they just weaponize that. Think about any attack, just anyone, just throw one up at random, and you know for a fact PowerShell is in that kill chain. Even something like Print Nightmare. Think about that. Your spool service, the one tool on the machine that is designed to handle printing, could execute code because of a vulnerability. That's a feature. So we say take control over what's there, and you get to sleep better at night because it can't walk out of that lane. And it should be that simple. So that's all it's about. You can have everything to tell you that there's something bad going on. But at the end of the day, your team is left to remediate. So what we're saying is that we know nothing should touch your backups to begin with outside of your backup tool. And that's all we allow. Think about that. Every major vulnerability led to someone's backups being encrypted and exfiltrated. And you know, those big companies, they live on this side of the triangle. And that's all we're saying, just shift the perspective. If you have control, why not use it?
How does policy automation work? You know, if you get an enterprise that has thousands of applications, how do I know that this application has an interdependency of PowerShell and the web browser and this and this, and say I take the zero trust approach and say you can't touch anything. Break the app.
You break the app.
Break the app, right? And then you permit some of it, and then maybe other components
Are broken.
Some of the app is working. How does threat locker?
How do you, right, and I love that question, and it's because from a technical perspective, what we are all used to, you deploy a group policy, you force it to update, you wait patiently just for it to break something, and then now you're picking up pieces after the fact. That's how we all grew up in this space, piece by piece, and it's a trial by fire. So what Danny Jenkins, this really smart dude, decided to incorporate is the ability to simulate any policy control you see fit. If you're looking to lock something down before we make your day miserable, you can see exactly what that looks like. So when we implement, we go through this learning process. And to give you an idea, we deploy on any number of devices you choose. Realistically, more endpoints the better, because now we're giving you the full picture. So think about being able to pop into an audit. Instead of you combing through an event log to figure out that you broke that codependency between PowerShell and that line of business tool, it's just all there in one place. One of the things I love to sell on for the tech team is the fact that you guys will never have to ask an end user any questions whatsoever. If something happens, you have answers. You have the ability to say, I need to know everything Google Chrome has done in the past 30 days tied to any user, any point in time. And you get that in seconds. So if we can provide you that visibility to begin with, then locking that down becomes really simple. We, as an engineer, tied to Highpoint, I don't want them getting tickets, because that means I get tickets. No one needs that. So when we onboard, the goal is to make sure it's palatable. We can limit any type of interruption because of how we deploy. So when the agent gets installed, it's going to learn about what's going on there. Who uses Chrome, who uses Firefox. It builds those policies automatically, and you get to fine tune as you see fit before you go into production. So it makes it really straightforward as far as getting the policy control in. And then my personal favorite, whenever you deploy, they're not gotchas, but you get to see remnants of old things that are out there. It pops up on every deployment. Old tools you used to use, you thought you offboarded, but that uninstall script covered like this much of the software. Old group policies, that's my personal favorite. When you bring on a new client and you have to familiarize yourself with the network, that's typically an ordeal. That typically takes a few months, you guys sending people out physically to understand how things work. And that's something we completely eliminate because it's all there. If a script executes, you see it. So that's where the visibility comes in. You get to see exactly the network for what it is and then make the changes. That makes sense.
Do the policies get granular enough in the fact that I can say this application
So
Or more at the only the whole application?
it can, and one of the reasons why, again, I like to pick on vendors, when we take full control of PowerShell like that, some other tools don't like it too much, and they're typically other security tools. So what we say is, based on the relationship, if PowerShell for a user, for one task, needs the freedom to touch this site on the internet, you can define that. You can even schedule when that allow should take place, and you revoke that privilege afterwards. So from a policy perspective, one thing I'm a big fan of is that granularity. You'll see storage control here. One of the things I got a super big technical win for was a medical clinic. Their HIPAA requirements forced them to limit USBs, and the only thing those USBs could be able to touch were images. And you get to compound those conditions as you see fit. And it's not all images. They're the types you feel comfortable with. So it makes it really simple for you to dictate to the T exactly what should transpire, and you block everything else.
One other thing I would add to that, I think we are pretty much at time, or we are over time a little bit, but one other thing I would add is there's a whole lot of applications in your environment that are the same. You all use a lot of the same applications. And one of the things that ThreatLocker does a really good job of is, what do we call it, crowdsourcing? Basically crowdsourcing policies. So all of those applications that you all use that are standard are already policies built with ring fencing that works great for your environment. So it's not like you have to start from scratch. When you start deploying, there are already policies from applications we've been detected that can be applied if you choose to do so. Otherwise, you can build them from scratch, and it's still not hard to build them from scratch, but you have that ability.
The no-brainers, the browsers, meeting tools, the things people will target, Office, you get those things from the very beginning. But to kind of set the precedent, we have over, 3,000 what we call built-in applications. And that's where you get our team's value in saying, if TeamViewer, if QuickBooks, if one of these vendors release an update, we're not just scanning its certificate to say, yes, this is legit. We capture it all. We
What the
go
files
back
are.
to the vendor and say, this is what we found. Is this real? And they give us a yes or no, and that goes out into production. So if feel free to hop on to Reddit, anything on the University of the Internet itself, and the track record honestly speaks for itself. The one thing I will say to kind of get your gears turning, think back to the supply chain attack with Kaseya. Kaseya VSA is a ThreatLocker built it. Kaseya is also based out of Florida. When the supply chain attack took place, there were 3 files baked into that package, and they were signed by a vendor in Canada. And we saw AV tools let that pass just because they were digitally signed. But one thing we know, Microsoft also signs malware. So that's where we get to make the difference. If we can validate what's supposed to be there from the beginning, 0 days, supply chain attacks, things of that nature, we worry less about because the identity piece was already taken care of.
Yeah, so I guess we are over time. I appreciate you all coming. I hope this was helpful. I feel like Colin answered more questions than I did. This is why I love working with Colin, so thanks you guys.